FameLab, talking science.
So my mom called me the other day. She just read an article about cancer. I, being the biologist in the family, got the first phone call. She's like, it says, cancer is caused by upregulation of cancer-inducing genes. The word upregulation really caught her fancy. She was like, what do you mean upregulation? Is it like the knob of my oven that I can just put it up or put it down? I mean, if it goes up, how do I put it down? I was like, whoa, those are loaded questions. And as a biologist, wish I had an answer to all of that. I'll tell you what I told her. It's not the cure to cancer, but of course, it will help you understand how genes get regulated. So each one of us sitting here is made up of thousands of cells. Each cell in our body has the same set of genes, and these genes make proteins. Now, some proteins are needed in all the cells, so the genes making those proteins are active all the time in these cells. However, only a different set of genes have to be activated and other set deactivated in a liver cell in comparison to a skin cell to have these organs working properly so that they can produce different kinds of proteins. And this is where transcription factors come into play. Transcription factors are also proteins, and they help our cells, which are so different from each other, to have these various functions despite having the same set of genes. So now you'll ask me, okay, transcription factors, but what are these? You can consider them to be something like molecular keys. These keys unlock specific regions on the genes which promote its protein production. So a general gene, which is making a housekeeping protein for a cell, has only one lock that needs to be opened. And the key that opens it is the general transcription factor. But a gene coding for a protein, which has a specific cell type, needs to open two locks. And the second lock is opened by the specific transcription factor. So how do these two keys work? You can imagine them to be like a safe deposit box lock in a bank. So the general transcription factor is like the key of the bank employee. It unlocks the mechanism for locks of all the boxes. However, it cannot unlock any of the boxes. And you have your specific transcription factor, which is your personal key, which maybe you got from your grandparents or their grandparents, which has some valuables inside. And this will unlock your designated box because it fits to the lock, but it can't open until and unless the bank employee's key is also inserted. So now what happens if your special transcription factor is broken, or damaged, or lost? You're in trouble because you cannot get your valuables. The same way, if a transcription factor is lost in the cell, or is broken or damaged, there's deep trouble for the organism because it cannot control its protein production. And if there's too much protein being made or too less, diseases like cancer happen. So of course, you can turn down or turn up the genes, but first you need to find out which gene and how to do it.